Hello. Welcome to Calculus in the PM. I'm your host, Mr. Shindelka. And hot dog, we got an out-of-sight class here. Higher order derivatives. Now, there's nothing much to this, actually. It's not a bad little section here. Let's take a look at an example and you'll see right away. So this function is given. F of x equals, okay. I want you to take a second here and actually find the first derivative. That should not be anything new to you. Do it right now. That should be fast. Give me 10 seconds or a little more. Okay. Hopefully you've got it now. 6x to the 5. 20x cubed minus 9x squared plus 1. Okay, the new thing, higher order derivatives. Right here, we've got f with 2 tick marks, f double prime. We call that the second derivative. And the second derivative can be notated with f double prime, or it could be notated if you're using dy by dx notation. You could notate it like this. Just write this down too. d2y by dx squared. Okay? Or d squared y by dx squared, some people say. That's the same as f double prime. Second derivative. Now, we're going to stick to the f prime notation because we originally had function notation there. So let's do this right over here. So the second derivative, f double prime. Wait a minute, you're saying, how do I do this? It's not too bad, guys. What you need to do to find the second derivative is find the first derivative and take the derivative of that. So here's the first derivative. Take a second. Find the derivative of that expression, you've got the second derivative. I'm waiting. Yep, Randy, you work on it right now. Yep, good. Okay, let's compare answers. Don't just wait for me, I hope you have it done. Okay, let's go with it. First one, 6 times 5. 30. 4. 6 x squared minus 18x, and the plus 1 zeroes out. Okay. After that, you see how a third derivative would work? You take the derivative of the second derivative. You notice the notation for a fourth derivative, you don't put 4 tick marks there. But a fourth derivative is the next. Take the derivative of the third derivative, and so on. You might even be thinking, hey, if I keep doing derivatives, this will eventually become 0, and yes, it will, if you start with a polynomial. Yeah, it will. I don't need to beat this one to death, but there you go. So typically, though, first and second derivatives are what we're after, because they have more applications with problem solving. Why would you study these things? Well, here's one example, I'll just mention it. Recall the terms distance, speed, and acceleration from Science 10. You might or you might not. It's been a while. These concepts will be explored further in this course. Hopefully you're also in Physics 30 so that you have a deeper understanding of velocity and acceleration. Anyways, in physics you probably come across this equation. You probably have the half though written like this. It's just I was lazy when I was typing. I didn't want to get into the 1/2 at squared, 0.5 at squared. I just want to open up a second application to type the fraction. That's the only reason why. So, if you were to graph distance and time for an object that was like a baseball thrown right from your hand straight up until it reaches as high as it can go, then it's going to start falling. Well, this is only on the way up. It would covers zero distance when it's just leaving your hand, but as it goes, it's coming out fast, and eventually it slows down. Do you notice that? Right out of your hand, the slope of the tangent line is pretty steep. It's the fastest right out of the hand. As time goes on, it starts slowing down. 3 seconds later, it's coming and it'll eventually stop, zero. That's just the tangents there. That's a distance time graph. Now the same information though, given on a velocity time graph here, it's the same information right here. Now look at this. The velocity straight out of your hand, the same baseball thrown straight up in the air. Starts with a high speed. Over time it starts slowing down. This is giving speed, remember, or velocity if we're talking about direction as well. Eventually it comes to a velocity or speed of zero. And then it starts falling down, but I didn't graph that. Guess what? The first derivative of a distance function is the speed. You might be thinking, okay, I don't do it that way in physics. No, somebody's done all the calculus for you and they just gave you the formula. But just think of this. Now, if we take the first derivative of that distance function, we should have speed. So this should give us the velocity, or speed. Now, we won't use d by d, or dd by dt, because that would be confusing. I'm talking about, normally you say dy by dx, but when you start with the d for distance, it kind of looks stupid when you say dd by dt. So we're going to just skip that for now. You could say d prime if you wish, but that's not used in physics typically. We're going to just skip and say we know the derivative, because we're just told that. The first derivative of the distance function gives us velocity. And do the first chunk. The derivative of v naught t, where v naught is the starting speed, so like 2t, 2 meters per second or something like that, will be v naught. T is the variable. V naught represents a number like 3 or 2. So it's going to be v naught plus 1/2 at squared. What's the derivative of this chunk? 1/2 at squared. Well, the t squared, bring down the 2, it cancels with the 1/2, and you're just left with at. If you're in physics, maybe you recognize that equation. Somebody's done the physics for you when you have all those different physics equations. Or someone's done the calculus for you when you get all those different physics equations. That's why this works. But this is a formula that only works when acceleration is constant. Then you might see if you took the second derivative of this, you get acceleration. But guess what? This zeroes out. You just, in the t, get rid of it. You just got a of t is equal to a. That doesn't tell you a lot, because that's where the acceleration is constant. But the second derivative of distance gives you acceleration. It would be a constant in this case, in the case I gave you. Anyways, enough about that. You can try some of those problems. So you're going to try on page 124, 14, 24, and 35, and then try these. Now, because those are evens, the 24 and stuff like that, I gave you the answers right there. For 14 and stuff, take a look at the textbook that's just in front of the desk there if you need the answers. Now look at this though, the digging deeper here. Shown it right is a graph of the functions f of x and g of x. So here's the f of x function. It's the thicker dark line. The thinner line is the g of x function. Okay. Now, assume that big F of x is equal to the product, f of x times g of x. By studying this graph and using the product rule, find the value of each of the following. F prime, big F prime of 2. I'll do the 21 with you, just because I'm not here to help make sure you guys are getting started there. So let's try that one. Maybe I'll use some color coding. So I'm going to do 21 there. F prime of 2 is equal to. Well, let's apply this rule here. Remember, this is a product here. F prime of x times g, or f of x times g of x. Sorry, I'm starting to get into the rule in my head here. Wouldn't that be equal to derivative of the first thing, so f prime of x, times the second thing left alone, g of x, added to the first thing left alone, f of x, times g prime of x. Okay, that's the first thing you got to do, is understand the product rule. By now you've used it enough. You should have it in your head. You might not, but try to. It'll just save you time. I will give it to you on my tests, but you should use it often enough. It'll slow you down if you keep looking it up. Now I'm just outlining what I did for f of x here. I'm doing it in blue because I used that color here. At least I'm close to it. And the g function is this thin one. My board isn't perfectly synced here, so I'm off the lines a little bit, but not too bad. So I'm using green for the g, blue for the f. Now you might be asking, at 2. I guess I should have had 2's in here, by the way. It's okay, I don't need to. You don't need to rewrite it. I think you understand. What I did was f prime of x, I guess. So I'll take those away here. But I just realized my mistake there with my notation. To make this better, I'm just going to fix this and say f prime of x of 2. Oops. I'm doing the same mistake. F prime of x. Sorry. Now, we're going to evaluate f prime of 2. Well, we need to find f prime of x at 2. And you say, well, how do I do that? Well, at 2. Right here's 2. The f prime function is here. So at 2. Remember, the derivative is the slope. And this is a straight line portion, so we can calculate the slope just by looking at it. Do you see that it's a rise of 3 for a run of 1? So the slope is literally 3. I replace f prime of 2 with the number 3. And then g prime, or g of 2, not g prime. So I'm plugging 2 into this formula here. What's 2? Okay, well 2 for the function g right there is a negative 1. Then, this portion here, what's f of 2? So I say, well, 2 right here, the function's value, f of 2, is 1. And replace that with 1 right here. Lastly, g prime of x. So g prime at 2. At 2. What's the slope? Well, it's a straight line again. And do you see? Run of 1, a drop of 1. So it's negative 1. Okay, now you got some minor arithmetic to do here. 3 times negative 1 is negative 3 plus negative 1. So it comes out to be negative 4. Hope it does anyways. Actually, I see I have the answer right there. So there it is. Think about these questions, and I say that right here too. Really try these questions before looking up these answers here. So, here's 21 as I just did it. I forgot that I had the answer right there. So, don't just try it and say I didn't get it, oh, it's negative 3 halves and so on, or 2 or whatever. Really try them. Talk to somebody too if you need some help. Okay? Try these questions. This one isn't too bad, but it's kind of a doozy, like it's pretty darn big, this expression here. So when you do the derivative of that one for b, it gets pretty messy. But see if you can work it out. You don't have to simplify it to do it. Okay. Good luck, keep fit, and have fun. Whatever that's supposed to mean. See you tomorrow.